Okay, so why is web useful? Essentially, web makes up a massive portion of most pen testing engagements. This is because almost every case, but in most pen tests, web will be a part of it, and in some cases, it'll be a very large part of it. Like over 50% of pen tests will be web. And my internet connection is stable.
That's just UF.
Yeah. Intro, I froze.
Are you on Edge Room or UF Guest?
I'm on UF Guest. Edge Room doesn't work for me, so.
Really?
Yeah. We're gonna change screen. Oh, there we go. Okay. So OWASP top 10 is one of the bases for web exploitation. OWASP is essentially a security project. All of their work is open source. They also release lots of tools and guides online. And they every year they release a top 10 categories for what they consider the most vulnerable and most common vulnerabilities for web. So if you're not familiar with those, you should probably look that up and look through them. I think the 2025 ones are here. There's a lot of, oh, it's frozen again. Okay. Well, the 10th one's a question mark because this is somewhat speculatory because they are not very consistent in releasing their vulnerabilities. But a lot of time it's similar vulnerabilities. They just get moved around a lot and the group names get changed. There you go. Okay, so web reconnaissance is very big in web pen tests. A lot of time it consists of a massive portion of those web pen tests, and you need to be able to understand the attack surface of your application before you can actually get into it. And so a good way of doing this is, first of all, just clicking through source files. You can open up the source of any web application and just click through files to find endpoints, different things that are linked there. But also you should check for common files that a lot of web applications have. The first one would be robots.txt file. This is just to disallow and allow crawlers and robots to go around the site. Almost every single site will have one, big sites, small sites, everything. And a lot of the time you can find admin endpoints or other endpoints that you don't want robots crawling to on those robots.txt pages, which makes them very useful for finding possibly sensitive endpoints quickly. Other than that, sitemap. Less websites will have sitemaps, but still very common to have. And they essentially just list out, I guess, a sitemap. It's very self-explanatory, but it's an XML file that just gives you contents of that site and lets you reach them easily. .git. This one is very common in CTFs. You won't find it on many actual websites, but it is a misconfiguration if it's there, and it lets you provides Git histories and other hidden folders that you're normally not supposed to have access to. And then I think this is the last one, HTA access. This is specifically for Apache web servers, but it potentially allows you to write stuff to the server. This isn't common again, but it's occurs in some CTFs, some challenges, stuff like that, and can lead to RCE, which is, I guess, the end goal of a lot of web exploits. So for reconnaissance, other than just like hoping for these pages to be there, you're gonna have to do your own reconnaissance, look for your own stuff. So common methods of doing that is fuzzing with tools like Fuff, GoBuster, DirSearch, stuff like that. And essentially fuzzing is where you take a word list and you throw it onto the end of a URL and just fuzz for files. Like say you have ufl.edu, for example, you take a word list of possible files and it'll just search through them one by one automatically, and it'll return results like that. Additionally, you'll want to use Google Dorking. I think somebody covered this in a GBM at some point. I think it might have been Andre. Yeah. But it's just advanced Google searching, I guess, finding endpoints more easily. You also want to be able to filter through these fuzzing results because a lot of sites are very, very, very massive. This might not be the case for many CTFs, I guess, and challenges, but in a real pen test, it'll be very large attack surfaces. A single company can have hundreds of subdomains, and each of those subdomains could have hundreds of pages, and it's just a mess to look through. So you want to have some way of filtering these results to look for stuff that you want, and that's where filtering tools come in. Other than that, you have site spidering, which is a bit more of a passive reconnaissance method. It still accesses the actual site, but instead of brute forcing pages, it goes essentially from one page to another and just goes through the source code file, similar to what you do. What's that?
How does it go through? Is it like clicking links?
Yeah, essentially. So, when you open up the source code for the front end of a web page and it shows reference links to JavaScript pages or other endpoints that it's using or it links to, spidering tools will essentially just go into that and crawl between those pages. So they won't brute force anything. They'll just like go through the pages that are already provided. It's just an easier way of looking through them instead of just going through them yourself one by one. And then the last one that I'd recommend for recon is the Wayback Machine, which is, I guess, a bit of an outlier. I didn't think it was that useful when I first started off, but it is actually very, very helpful in finding old files. So if you think about it, if somebody misconfigures something and exposes a sensitive file, this could be like 5 years ago, 6 years ago. Wayback Machine will have that a lot of the time. And many sites won't bother checking to make sure that their data gets taken off Wayback Machine. So they might make that file a 404 now, but if you go back to that file in like 2017 or something on the Wayback Machine, it might still be there and have sensitive data. So that's a pretty big one. And essentially there are lots and lots of tools for automation in recon, and you kind of just have to make your own methodology, I guess. Find a way that you like to go through pages, find a way that you like to basically go through a site and find sensitive endpoints and make it your own. So that's for that. This is just an example of a fuzzing thing. I won't go through many of the actual reconnaissance tools because there's a lot to choose from and they have a lot of flags and it's kind of personal preference. But a classic reconnaissance tool will look like this. This is GoBuster. You provide a URL, you provide a word list that you want to fuzz for. And it'll take all the words in this word list essentially and just shove them onto the end of google.com and just fuzz for them. And it'll return the ones that return with status code 200s like this. And you can filter them by size, by status code, by anything essentially. And you can find pages that exist. Now cookies, this is somewhat essential to many web applications. So when you have a web application, you have a login, you put in your username and password, right? But then once you go between pages after that, it somehow maintains your session. You're not sending your username and password with every web request. Instead, you have assigned what's called a cookie, or sometimes there'll be different forms of identification, JSON web tokens, other things like that. But essentially, this is a token that is linked to your session. So every time you send a request with that cookie, the web application knows that that's your session, that you're the one using it, and it returns your resources for you, right? And so these can be accessed just in the normal edit this cookie extension, or just in normal control, whatever, what is it called? Inspect element. You go to inspect element, go to application, and under storage, you should have cookies around here. And this is applicable to most websites that have logins that will have cookies of some sort. And these are always automatically sent with the web requests you have. And now to the web exploits, the fun part. So the web exploits I'm going to be focusing on for this speech in specific will be mostly the easier ones to understand, the ones that don't require a lot of technical knowledge to get started with, because it's a fast meeting. I want to cover stuff as quickly as I can. But before we get into that, we should do web request basics, I guess. And web requests are essentially how you communicate with the web server as a user. And they come in many different types. The most common ones will be GET requests and POST requests. And so every time you visit a website, you try to go to another page and you send a web request, your computer will send a request with headers and data to that web application, and the web application will respond with the data you're requesting, or if it doesn't have that data, it'll respond it doesn't have it, or accordingly like that. And so the two main requests you're going to be looking at are GET requests and POST requests. GET requests are common for getting static pages or getting information, essentially stuff that's like you're not sending any information yourself to be stored in the web application, you're just getting pages for yourself. And GET requests will always have their data sent in URL parameters. It'll never have a request body with parameters. It'll always be in the URL here. You can see user and pass at the top. This is uncommon, by the way. You normally won't have user and pass sent like that as URL parameters, but in this case, I guess it's a good example. And then post requests. Okay. So post requests are different in the sense that they don't send URL parameters. Instead, parameters are in the message body here. And these are commonly used for sending information that you want to be stored or updated. And again, these are interchangeable because a lot of devs will use post requests for functions that are normally associated with GET requests, or the other way around. It's kind of up to the devs, so it's kind of hard to anticipate what pages will have which. But yeah, those are the two most common types of requests. There's also put requests, delete requests. Devs can implement their own custom requests. It's really depends on the web application itself. But I'm going to try to demo if I can. I'll use burp screen, I guess. Does it work? It does work, okay. So Burp Suite is a tool for proxying web requests. There's other tools like OWASP, Zap, Kaido, other things like that. But essentially it lets you intercept a web request and see it easier, so put that here. And if we go to ufl.edu, here's for example. Okay, fine. Okay, maybe not. Trying to find some website. There we go. Okay, so you have a site like this, right? And you can see if you go to inspect element, there should be a network tab. You can see your requests in here with the if I refresh the page. These are all the web requests being sent here. And essentially what Burp Suite does and other web application proxies, they just make it much easier to see these requests. So instead of looking through this mess, we can go to Burp Suite or whatever web proxy we're using, turn on the intercept, and that's the wrong thing. That's also the wrong thing. Okay, here we go. And refresh the page once more. And this time, Burp Suite captures it before it's actually sent. And here you can see the get requests and post requests we were talking about to get different contents and stuff like that. But essentially, post requests, as you can see, no URL parameters. All the parameters are in the request body down here. And get requests, they don't have a request body. Instead, all the parameters are up here as things like this, where it's a parameter in the actual URL itself. And this will be important for later, so we'll see. But yes, I hope that made sense. Okay, so moving on to actual vulnerabilities, the fun part. The first one will be HTML injection. And this is probably the most simple vulnerability you can find, one of the most simple, but it is when, that's misspelled, it should be style, but whatever. So HTML injection is when your user input is not sanitized and it is reflected back to you on a page somewhere. And you can inject actual HTML code, CSS code, and edit a web page's contents essentially. And there has to be somewhere for this to be stored or reflected back on you to count. But it's basically when you hear people talk about defacing web pages, changing its contents, it's HTML injection they're talking about. They're basically injecting HTML and they can delete elements, they can revamp the entire page. But the important thing about HTML injection is that it cannot have on-event listeners and stuff like that. So essentially you can't steal data from other users. You can't do any function that requires JavaScript because this is just HTML. So say you want to make a fake login page for phishing. HTML injection could help with that. You can make an entire fake login page on the target site, steal user data, but it won't do anything because the login button can't send any requests because it's just HTML. And that's where XSS comes in, cross-site scripting. And cross-site scripting is essentially just JavaScript injection, basically HTML, but upgraded. And there are many different kinds of cross-site scripting, but the end result of cross-site scripting is being able to execute JavaScript code on a victim's page. And a lot of the time this can help with stealing sessions and phishing mainly. Those are the two main uses. But the main types of XSS are reflected and stored XSS. And there's also DOM XSS and self XSS. There are other kinds, blind XSS, I guess, but these are the main types of XSS that you will see. And starting with reflected XSS. These are all similar in the fact that they store JavaScript on the target page and execute it. But reflected XSS is considered non-persistent because your data is not stored in any database anyway. Reflected XSS is where, say you put in your username on a website, asks for your username, you put it in, and the website responds like, hi, blank, and tells you your username, right? That is not getting stored anywhere. You can't send that hi blank page to a victim, or like, you can send it to a victim, I guess, but it's not stored on the website itself. It's a custom page just for you. And essentially what you put in is reflected back at you. So if you put in an XSS payload, that XSS payload will be reflected back at you and you can execute that to steal cookies. And that means this is always done through GET requests, at least to be effective, because you need some way of delivering the reflected XSS to a victim. It's not stored anywhere. So this, like if you find XSS in a comment section or something like that, that's not reflected XSS. Reflected means it's just for you. And so to actually get a victim to fall for this, you need to essentially have them click on your link. So that means it has to be a GET request because the parameter has to be pasted in the URL itself, like we talked about earlier. And these are some payloads and how it would essentially work is you have a URL like this in a GET request where your data goes up here. And you can replace that with JavaScript data. And instead it'll run this JavaScript and reflect that back on you and learn or basically run whatever is in the JavaScript tags. And now you can take this URL right here and send it to any victim. They click on that page and that script executes. That's how reflective XSS works. And it's commonly used to steal cookies and credentials, as stated before, for XSS. Stored XSS. This is essentially an escalation of reflected XSS, or not escalation, but it's like a more serious version. And this is where it's actually stored in a database somewhere. So think if you have a comment section on a page and you comment your XSS payload, and then another user visits whatever page has that comment section, that script is automatically loaded on their page. You don't have to send them a URL, you don't have to do anything. You can just, any user that visits that page, it triggers automatically. And this is a problem because basically any big page with user inputs, think a forum, think a chat log, anybody who sees your message or whatever will get that JavaScript triggered on their page. So this could be very, very big. This is how that works essentially. This is a graphic from Adam's slides. I don't know how great it is, but essentially, you create a post. So think if you're in a live web app chat, right? And you're chatting with other people, and someone sends a stored XSS payload. You can't do anything about that. Like that XSS is sent in the chat, it triggers on your page, the page of everyone else viewing that chat, and that's stored XSS, essentially. And then we get to the less severe versions of XSS, but they can still be important. DOM-based XSS. In this XSS, there's no, essentially there's no request to the server itself. So reflected XSS, stored XSS, they both send requests to the server, and the server will just send information back, including the page. DOM XSS uses the JavaScript document object model, which essentially lets a web page load resources somewhat dynamically without actually sending web requests. And this can be important because it is a client-side attack and the server itself does not log any of this. And it sounds somewhat useless because how do you send a request like this without getting feedback? So how do you send it to another user, essentially? Well, DOM XSS can still take information from the URL or other fragments inside the page itself. And if you can get a user to paste that same URL, even though it does not send it to the web server, the document object model will automatically evaluate it. So I guess somewhat similar to reflected XSS, it just, the main difference here is that it does not send a request to the server, and it can be executed through functions in the JavaScript. This one's a little difficult to comprehend. I couldn't get this when I first learned about it. It took me a while to understand, so it's okay. It's a little confusing, hopefully. But moving on to the last one, easiest one to understand, the dumbest one, in my opinion, self-XSS. So self-XSS is essentially XSS that you get on a page, but there's no really way to make it into an attack vector. It's not stored XSS. It doesn't, like other users can't see it. It's not in a GET request, so you can't send it to other users as like reflected XSS. It's quite literally, you put in a payload somewhere on your page, and that payload is reflected back to you, and you have no way of sending it to someone else. So think going to the console in your web page and putting in a payload there. Like, how do you send that to another user? So that's why this is pretty useless. Essentially, if you get self-XSS, it's just like at that point, you might as well tell the victim to open PowerShell and run some random command, because that's really the only way to get self-XSS across. And now on to payloads. So first, you normally want to check for HTML injection, as said before, and then you want to try to escalate that to XSS and see if you can get both. And you can use those together, as mentioned earlier, to steal user information, like cookies from XSS. Or if you want to create an entire fake login page that functions with XSS to basically send those cookies to yourself, you can do that as well to steal user credentials. And commonly, when checking for XSS, you use the alert tag and then alert document.origin or one. So that's just a common practice for checking. You can really use anything, but the benefit of using alert is it's easy to notice. The benefit of using document.origin or something like that in the XSS tag is that it reflects the origin back to you and basically makes sure that XSS isn't in an iframe or something, which we won't be covering, but that is something to check for. You'll want to send these requests to yourself. You can use these sites, webhooks site or request bin. You can also just start your own listener, send a request to your own page with the user's credentials. And in CTFs, this is in most situations, actually, this is basically just used to get cookies. So you run document.cookie, that gives you the cookie with the XSS, and you can attach that, say you run a listener. You can put your IP so that it sends a request to fetch your IP, and just add the document.cookie as a parameter at the end and steal the user's cookie. And more payloads. Let's skip the page. Okay. So this is what I was just talking about, I guess. So you add your webhook and then document.cookie at the end, and it'll send a request to your webhook, and you can see the cookie attaches a parameter at the end and basically steal the user's session and get into their stuff. Oftentimes there are filters in place and script or other things won't work. So in this case, you can use other alternate payloads. There's a lot you can use. This is not all of them, but essentially, this does not work because I copied this from Adam's slides. I'm sorry, but there are good resources on the payloads of all things repo and other areas where you can find XSS payloads. And essentially, all these do the same exact function, just worded in different ways to bypass filters. Like say script doesn't work, then you can use image SRC or SVG onload, things like that. And I think most of these payloads are pretty self-explanatory. This first one, for context, is trying to load an image. X is an invalid source, so it refers to on error and runs your JavaScript code. Now, custom bypasses, I guess. So eventually, when you want to get better at XSS, you can't just blindly shove in payloads and hope it works. You have to actually analyze what the filter is doing, what's happening to your payload, and analyze it and change it accordingly so that you can get that XSS you want. And many times this will involve like painstakingly going through one block-listed character after another and trying to find what works. And it'll come up with some crazy payloads like this one at the bottom here, using characters like this. And this was actually used on the Nepal government website, but it's just, you can get some crazy stuff, but to make these custom payloads, you essentially have to put in a payload first, analyze what's getting filtered, change that, and just keep doing that over and over and over and over until you get it working. And here's some resources for XSS if you want to get more into that. These slides will be posted later. Cross-site request forgery. So this is the next vulnerability we're going to use, and this one's actually nice because you can chain it with XSS in some cool ways, but we'll get to that in a second. So cross-site request forgery is basically where you have a malicious website, and you can make that website send requests to another website where the user is logged in. This is because browsers store cookies, so those cookies are automatically attached to requests the victim makes. So if you have a website that requests a resource from another website, and it does that in the user's place, that user's browser will attach their cookies to the request, and it'll perform those functions on the other website as them logged in, if that makes sense. And so here's an example, I guess, that might help understand this because I don't know I explained it too well. But if a victim's logged into a website, their banking website, say, their browser has that session cookie for them. And then you have your own website, say evil.com. You can get the victim to visit your website, and then your website will automatically send in that victim's place a request to bank.com. And their browser, the victim's browser, will automatically attach their cookie as a header because that's just how it works. And it'll essentially perform unauthorized actions on that site for you. And so basically this and XSS are two of the big reasons why everyone shouts that you don't click on random links. That's why. I will say a lot of sites have good protections against this, and browsers also have inbuilt content security protections against CSRF, but this guy's
Is this what CORS is for?
yes, but CORS misconfigurations are
Annoying,
so, yeah.
What keep you safe?
Yeah, but Poison's cross-origin resource policy, something like that. So I forget the exact thing.
It's very close.
It's essentially to stop stuff like this from happening. And many web browsers have inbuilt protections against this. So if you're trying to exploit this in something like a CTF, you might have to use one of the web browsers that doesn't have such protections, like a watered down web browser, I guess. This is the website similar to what we were talking about, where it's an example. And essentially, this would be your form action on the banking website. So you can go to the banking website, see what happens when you're trying to transfer funds. And this is what happens. There's no anti-CSRF token, nothing to keep you from doing CSRF. So essentially, you can make your own website, evil.com, put this code in it, and when the website loads for the victim, it automatically sends a request to bank.com/transfer, same exact form action as this, same exact parameters, but the user's cookie will automatically be attached because of how the browser works. And so it'll make a request to the banking account. That makes sense. Yeah, good. Yeah. Into chaining vulnerabilities. So chaining vulnerabilities is a massive part of web attacks, I guess. And this is a small example of that. So similar to how we mentioned earlier, self-XSS, completely useless. What is the point? But if you find CSRF, you now have a way to get that self-XSS on the victim's site. So say you had self-XSS because your XSS was reflected, but it was in a post request. So no URL parameters, you can't just send the URL to someone and have it trigger. And you essentially just need the user to type that into the form. Well, now you can use CSRF to type that into the form for the user and get that reflected XSS without worrying about URL parameters. And that's just another way you can steal credentials, hijack sessions, stuff like that, without worrying about the whole self-XSS thing. And now moving on to insecure direct object references. Sorry if I'm going a bit fast, I'm trying to cover everything. But this is arguably the easiest web vulnerability you'll ever see. It's essentially just when a direct object is referenced, and you can just change that to another user's object. So think this is a really simple but really obvious example of why it's so easy. Say you have something like this, where your user ID is clearly defined in the header, user ID 25. But what if you change that to 26? And then now you just have user ID 26's information instead. And think this could also occur in situations where, like, say you're editing your profile page on a website and you see a URL parameter. It says like ID equals 2400 or whatever. You change that to 2401, and now you're editing some random person's profile. And that's why that can be dangerous, yeah.
So does this only happen through URL parameters?
No. So this any parameter really. Say you're doing a post request and it's being passed through the body. Again, it's the same exact thing. You're sending a request for page 25 or user 25, change it to 26 and it works. And this is also where cryptography comes into play in web requests a lot of the time, because you'll have parameters that have basically obscured payload, not obscured payloads, but obscured user IDs, things that define sessions. If you can find some way to decode that and make sense of it, you can change it to another user's session. This is basically anything where you can enumerate user IDs or some sort of user identification to gain access to someone else's thing. And now a directory traversal. This is an equally simple, I'd say, vulnerability. It's mainly about getting files, so local file inclusion. And you can see that. So oftentimes you traverse directories in Linux by using this // method. Windows would be, I guess, opposite slash, but if a website is in the var www HTML folder and it's serving a page in there, what if you add this to the end of your URL? So now you're requesting site.com and then going back in several pages to get past this HTML www var stuff, and you now try to access Etsy password. Well, some websites will let you do that when they're misconfigured. And this isn't just a URL thing. This is essentially anywhere where this comes into play in a lot of more advanced exploits, but anywhere where some sort of file path is mentioned, you can try to throw this in there and get access to files you're not supposed to, and you can read internal resources. Resources for that. Now, SQL injection. This one will be probably the more complicated one on these slides, but I'll try to explain it in a simple way. So SQL injection basically abuses the structured query language. You also have NoSQL injection, but that's just similar, just other languages. But essentially, there are lots of database languages, lots of types of SQL, as you can see here. There's also more, it's not all of them. And every single one has its own unique language for communicating with a database. And you'll see SQL commonly looks like this. And this is how you reference user logins, user stuff. So when you try to log in, for instance, you put in a username and password. The application will look in its database with an SQL operation and look for a user that has that username, has that password, and it'll log you in as that user, right? And so this is what SQL data looks like, essentially. It's just rough, but it'll be inserting tables, dropping tables, selecting from tables. And that's where you get into attacking these SQL databases. Because say you have a line like this for authenticating users, right? You're selecting anything from the table users where the username equals, and then this is the user inputted username, and the password equals this. And if there's no sanitization on the front end or back end for this, a user can just put in whatever the hell they want, and they can mess with the syntax. So say a user puts in admin apostrophe dash dash. Now I'll be selecting all from users where the username equals admin, and then the dash dash will comment out the rest of the query, and I'm just selecting users that equal admin. There's no check for passwords, nothing. You get logged in as the admin. So you can see how that's a problem, obviously. Example I found in Adam Wild, Adam found this in the wild. I stole a slide from him. But like this, for instance, where it's selecting all from users where username equals the user's username. You can just use any user username and comment out the rest of the line and just get into any user's account. And this can also happen in the password parameter as well, where you want to target a specific user. So you put in the user's username, and then here you use the payload or 1 = 1 -- in the password field. And so essentially this selects from users where the email equals the email you input, and the password equals blank, or the password equals 1 = 1, or 1 = 1 is true. Because 1 = 1 always evaluates the true and never checks for this, and this always checks for the email, if that makes sense. Yeah.
Yeah, so for this example, why wouldn't we just do the SQL injection on the email?
You could, essentially sometimes only, I mean, rarely, I guess, but only one would be filtered.
That's the new
Also-
line, so
What's up?
that's the new line, so it'll still do the.
Yeah, so it'll only check for one essentially, but because you can't comment out the password line here, if it makes sense, because the password line is on the same line, like you said. No, more advanced stuff. There's a lot to go into database injections and SQL injections. You have to take in the version of the database because different versions use different types of languages, different syntax. Also, you often need to have proper parameters, proper amount of table rows that you're selecting for it to work and the SQL injection to not fail. So you need to use union attacks for that. You need to bypass sanitization. Blind attacks is when nothing's reflected back at you, no SQL error. So you basically just work purely off timing of things like you can delay the response time to see if that gets injected. Things like that. I won't cover them in this presentation, but if you want to dive into those, there's a lot of resources online for that. And now for automation, the single biggest automation tool for SQL injection is probably SQL Map. And SQL Map is very good at what it does, but it can also be very harmful because it can send a lot of data, a lot of requests. And so it has inherent risk levels settings that you can adjust for that. But just be very careful when you're using this tool. And like Adam says, don't put it on the UF network, please. But yeah, this can detect database type for you, automatically do injections, automatically dump databases. Basically, it lets you find a payload that will work, and you just roll with it. I guess it does pretty much everything for you. It's a funny graphic, but I guess this would be how a database injection might work. And now some more web attacks. There's a lot. These are just the ones I could name off the top of my head at 3 a.m. crying over my presentation. So, but there are more, and it's a lot. It's overwhelming. And then you get into combining them at higher levels, and you get stuff like this. And it's just like, what is happening? So a lot of web attacks can work off of combining vulnerabilities, chaining them together to get bigger impact. And you end up with some nonsense that's very confusing at first glance without a description. And so the way you get good at this and the way you learn how to do this is by learning web dev. I'm sorry, but I'm going to make you do it. If you understand how a web app works, you can break it. And if you understand how a web app works, you understand why different functions work the way they do, how they fit together, how you can chain stuff together. And so this is very important for web applications. You can get away with not knowing some stuff, but in the end, if you want to work on more advanced exploits and really understand what you're doing through the web app, you kind of have to learn web applications and how they work. And what's happening? There's a lot to learn, I guess. It's a lot. And there's a ton of stuff, and it's very overwhelming, I guess, is what I'm trying to say. But you kind of have to start somewhere, and you don't need to be an expert at everything. You just have to understand what different things do. Essentially, what is a content management system? What is a template? How can I exploit these templates? And you can Google the rest. You don't need to have this down by heart, but you should understand different languages, different functions that may be vulnerable. Just really try to get a read on how applications can be abused, because every application is unique in its own way. It has its own languages, its own frameworks, and each of those frameworks has its own vulnerabilities. And you can't just throw in a ASP.NET payload at a PHP website and pray for it to work, because it's just not. So you have to understand what's happening and what's vulnerable to what. And that's where you get to vulnerability disclosures. These are cool vulnerability disclosure programs, bug bounty programs. They're essentially freelance opportunities for web app work. It's part of why web apps are so cool and web app vulnerabilities are so sick. Essentially, you have these big companies that have already gone rigorous security training, have already had a red team pen test, already have an SOC team. And they'll put their web apps up and they'll be like, hey, if you can find these vulnerabilities in our web app, we will pay you for them. Some of them don't pay you, but some of them do. So that's cool, I guess. You can also get cool merch from it. It's just generally a really nice opportunity to test your skills. You do have to be careful to follow program scopes, program guidelines, because it can get very finicky with legal problems, but as long as you follow the rules, they'll be fine with it, I guess, and won't have to do. And final tips and takeaways. Essentially, you just want to practice your skills. You want to be able to build your own methodology, your own way of going through websites without worrying about what other users are doing, or like, you don't want to copy someone else's stuff, is what I'm saying. You don't want to like blindly throw payloads in, blindly throw tools in without understanding what they're doing. So you want to be able to make your own methodology and practice it over and over and over and refine it to do what you want it to do, what you personally are looking for, I guess, if that makes sense. And a very good way of getting better at web application vulnerabilities and really understanding what's happening is by making your own web apps, then finding vulnerabilities in those, realizing why they're vulnerable, and then essentially fixing that vulnerability and then trying again, trying to bypass the fixes. Yeah.
So when you say make your own web apps, there are all a bunch of different stacks out there.
Yeah.
You need to use all of them.
I would recommend trying to use the most common ones. Yeah, just try to get used. You don't have to be an expert. Like, you don't have to be able to open Notepad and code a full backend for PHP or whatever. You just have to understand what these different languages are doing, how they interact with content management systems, how they interact with templates, how they interact with databases. Just like get used to the common applications. Eventually, you'll lean towards like certain frameworks that you'll like better. And then I guess if you want to, you can go towards pen testing those frameworks in specific. But yeah, just practice. I guess this is probably the best way to get better at web application vulnerabilities, and it'll get you down on understanding how web apps work and why they work. Also, added bonus, you learn a lot of web dev skills. You learn a lot of DevOps skills by doing this. It's just useful for other things in general, not just security. And yeah, I guess you just want to learn how things work and really push towards one vulnerability and understand different bypasses, why it can be severe, how it can be chained to other things. Like, for example, say you find a local file inclusion somewhere. Well, I mean, that's a big thing, right? You can see local files and you may want to just end it there, but you can always escalate things in some way. For example, say you understand PHP, you understand how PHP works, you understand how Apache works as a web application service, how it serves web applications. And you notice that web applications with PHP running Apache have logs stored in a certain place. Well, now you can use that local file inclusion to look at those logs. And if you look in those logs, you can see that your user agent header is there. So what if you put in PHP code in your user agent header? And the way PHP and Apache works is when it serves a web page with PHP, it'll execute that PHP code. So if you have PHP code in your user agent header, and I'll include that in local file inclusion, you can get log poisoning and basically have a web shell like that. It's just things like small things like that, where it's very specific to a certain tech stack, a certain web application language, or a certain service, I guess, in ways. And you can exploit those vulnerabilities because you're familiar with them. And then, yeah. But I also have labs if you want to work on them. I will say I didn't do either of these labs. I like flipped through them. So I didn't make sure there were like write-ups online so you don't get stuck though. But I can't vouch for how difficult they will be personally, but I went through them and it's good information if you want to look at those. I think that's it. That is it. So any questions? Yeah.
Have you ever gone into legal trouble?
I wouldn't say legal trouble. I've been told off a couple times when you're first starting off. You just have to be very careful to follow program rules. And if you essentially do something you're not supposed to, or you do, even if it's something you're technically allowed to do, if they tell you to stop, you don't try to argue with them. Like, even if they don't have it defined that you can't do that, just like listen to them. They're the boss, I guess.
Are they specific?
Anything what?
Are they specific?
Yeah. It's just 18 minutes early. They could have used that. I can actually give examples also of some of the things I mentioned earlier, if anybody wants to look at that. But the actual recon stuff, because I feel recon is very, very big if I didn't stress that enough. When you're doing a CTF, a lot of time recon isn't as big. You can easily flip through all the pages, see everything, and just look straight to exploiting. But in an actual web application, you fuzz for stuff, you have like thousands of results, and you have no idea which ones are important. It's physically impossible to go through every single endpoint because it's such a big attack surface. So you have to get used to filtering those and learning which ones are useful. Like if you see API, if you see certain file extensions, you have to learn that those are the ones you want to look for. And I can show an example of that. I don't know where I put stuff. Here we go. So I guess I can start off by showing robots.txt files. So any big website will have these. You can go back to urfl.edu, let me, or they yell at me. But any website I can guarantee has a robots.txt file to keep crawlers. And this is just a good way of finding files. Like see, you can see a WordPress admin page here, XML RPC page here, which can be used for denial of service and stuff. But this is public information. Almost every site will have them. It'll rarely automatically give you an exploit or something vulnerable. But what it will tell you is pages that you can go to and check out that they don't want robots and crawlers going to by themselves. So that's what that's useful for. Also, like we were talking about sitemaps, they automatically provide a sitemap URL here. Some of them won't, but you can see a sitemap here, and you click through it, and it just shows different endpoints. And this, you can do all this without fuzzing or anything, without brute forcing anything. It just, the site just gives it to you for free, essentially. And you can see all these different things here. And what else was there? This is the sitemap like I was talking about. .git, they don't have that. HTA access, they don't have that. But Google Dworking, I'm not going to go over that. Purity went over it. It's very simple to learn on your own. It's just Google searching, essentially. Spidering sites, I guess. You can use a lot of tools for spidering sites. A cool one that I figured out is essentially, I have a bar at the top of my screen. Okay, so a cool one I figured out is if you go to a bookmark, essentially. If you create a bookmark and you add something in the URL, if you add JavaScript code in the URL or regex in the URL, you can run that JavaScript code when you click on the bookmark, which is actually really cool for creating your own web crawlers, I guess, in a way. So say I go to Amazon again, I'll use because it's a big website. And this is a bookmark, for example, that I have here. And this bookmark, you can see minified JavaScript code. And this essentially just, all this does is access the page source, like I mentioned, and visit links over and over and over recursively and just form essentially a spidered version of what's on the web app. And I can send this later as well at the bookmark code. But you just click on this, and it'll execute the JavaScript code automatically if it feels like it. And look, now you just have all this spider content here. And you can also just make fancier looking ones. You can basically do whatever you want with this. It's pretty cool. But that's a really good way of spidering stuff, and getting into JavaScript code is making yourself one of these, essentially. And this way you also don't have to use a tool for this. If you do want to use a tool that's better for this, OWASP Zap is a web proxy. They have a really good tool for spidering content and automatically scanning sites. But yeah, as you can see, it gives you a lot of content here just by spidering without any brute forcing again or anything. And the last one I'll show is Wayback Machine, because this is the one that's kind of odd one out. I first heard a lot of people talking about it, or not a lot, but people would mention it from time to time when I was talking to people about web app reconnaissance, and I'd be like, okay, I mean, I can understand how it's useful, but like, do I really want to go through that trouble? And I started doing it and messing with it, and the answer is yes, you do want to go through that trouble because it can give you a lot of content. So if I go to Wayback Machine here, I can essentially just search up any site I want, say urfl.edu again. It'll give me all these snapshots of urfl.edu. And the cool thing you can do is you can make your own basically thing, because the URL for web archive allows you to specify file extensions, allows you to specify wildcards for domains. You can basically create your own thing with pages you're looking for. For instance, this is meant to be a Linux command, but I'm just gonna do it like this. And say you do this, see it's specifying file types at the end. If you go to the front, it's a wildcard in front of whatever URL you want. So you can just do, say, urfl.edu again. And this will just return a result just from Wayback Machine of these files, I guess, that url.edu has. That makes sense. Oh, not .com. There you go. So urfl.edu, and it'll just return all of the files it has. And it has a lot on bigger websites. So you can see it's loading for quite a bit. I'm not sure if it'll actually crash my computer, but it can give you a lot of information. And the cool thing about this is, like I mentioned earlier, it shows you old pages. So you get one of these URLs, you're like, oh, that looks cool. You put it in your search bar and it shows 404 not found. The site doesn't have it anymore. But you can use Wayback Machine to look at Wayback snapshot of that site before it was removed. And if the company didn't explicitly try to get that information off of Wayback Machine, you just have that content now. And look how big these results are. This is how many endpoints it found. It's insane. So like I said, this is going on the fact that, like I said before, sites are very, very, very big. But now you just have all these stuff that you specify. And this is just with the file extensions I specified, just on url.edu, urfl.edu. And it gave me all this, I guess, which is crazy. And now you can specify, for instance, the pages. Like say you want to think of something, you can look for admin here, and you can just search through admin, anything that says admin and look for sensitive files. Or say, I guess this is a school, so grades would be sensitive. And you can just keep going through them like this. And you have all these files and PDFs and everything. It's like any of these could be, for example, you try to visit it on its own, right? This is probably not going to exist anymore. If it feels like loading again. Yeah, page 404 not found. But I can almost guarantee that if I use Wayback Machine, if I use Wayback Machine and paste that same URL into this, there'll probably be some sort of snapshot that shows me this file before it's edited. And this is old, I guess, but I don't think this is vulnerable because it's example grade, so I'm assuming it's not gonna have personal information. But as you can see, now it's available here, even though the actual site does not serve it. So this is why Wayback Machine is such a big deal and can do so much to basically find sensitive files, I guess. So yeah, I just wanted to show that because I didn't understand why it was such a big deal when I first started off, and it's actually very, very useful. So any questions, anything? Still have 10 minutes. Yeah, guess we're done. I don't know. Yeah, I tried. You know, probably.
Yeah, we're going to stop this.
It's soon.